Hey everyone, today I'll be going over two problems at once. 590, which is N-ary tree post-order traversal, and 589, which is the same thing but pre-order. So when we talk about pre-order and post-order of a tree, basically it means, think of it like as if we were recursively searching it and printing out each node value in the tree. Basically pre-order would mean that we want to print the current node and then search its left and right subtrees, and then do that repeatedly. And then post order would mean we want to search the left and right subtrees and then print the node. So pre means before, post means after, and this is an N-ary tree, so it's not like it's a binary tree, so there's not just left and right. It means that there's an arbitrary amount of children, and if you actually look, each node has a value property and a children property, which is a list of more nodes, basically. And this whole thing is a node. So let's just go ahead and, get rid of that. And let's just do exactly that. So we want the typical boilerplate for a recursion problem. And we're going to have some result, which is going to be an empty array list at the beginning. We're going to fill that result and with some recursive helper, and then we're going to return that result. So just a typical boilerplate, and I'm going to call this helper, and let's just assume that we're going to pass the root and the result. So let's mark this as private and helper and void because it's just a builder basically. It doesn't have to return anything. So what did we want? Well, it has to take some root and it has to take some result so that we can populate it. So we need a base case, as with all recursion problems, otherwise it'll never stop, or it'll get a null pointer exception. So let's make sure that this is not null. If it is, then we just break out. So what did I say about pre and post order? So post order here means, remember what I said, we have to search all the subtrees, then log the node. So let's search all the subtrees first. So to do that, let's just go through each child. So we're going to go through each child in the current roots list, so children, and then all we're going to do is just call this helper recursively on it. So we'll go this dot helper, and we're going to pass in the child because that'll be the new root for the next recursive call. We're going to pass in res. Now after we're done searching, so post searching, post order, we're going to add this to the list. So we're going to add the roots value to the list, because we want the output to be a list of integers, not a list of nodes. So we just want the value of this root. So let's go ahead and run this. And this should be good. Let's see. There it is. Let's submit it. And that's pretty good. And before I talk about time and space complexity, let's literally go ahead and copy this. Let's go over to the next one, which is 589 pre-order. And let's just paste this in. And this was called pre-order, so let's just rename that. And everything else is the same. However, remember, this is now pre-order, not post. So what do? We want to do this before we search the subtrees. So let's just cut that, and let's add it right before this. So log it, then search the subtrees. And let's run it on this one here. And let's submit it here. And yeah, this is pretty good. So let's talk about time and space. So time and space, it's going to be the same for each of them. So it's kind of like weird because it's like recursive or whatever, but realistically, we're just going through every node in the tree. That's all there is to it. And we're breaking out the moment we see a null node. So we are really just stepping over every single node in the tree. So as far as time goes, it's just O(n), where n is the number of nodes. And then as far as space goes, well, it's just constant. And the reason being is we don't count the output as space. When we're talking about time and space complexity, normally people don't count the output as any space. So we're doing O(1) because we're not using any extra space besides the output. So yeah, hope this helped. Got to cover two in one shot. So yeah, thank you. Thank you for watching.